Question show time. Your questions, my answers. As always, wherever you are, across my channel, if a question pops into your brain, just write it down. I'll gather them up and I will answer them here. And just a reminder, I record this show every Monday at 5 p.m. Pacific time on my YouTube channel. So if you didn't get an answer in the comments and you want to just hang out live, ask questions, ask follow-up questions, stick around for the after show, hanging out, you can go and do that on my YouTube channel, and there are live events when those are all happening. So I think you'll probably enjoy that. All right, let's get into the questions. Rowdy555. If the math showed Earth was 100% going to be struck by a significant global devastation, epic proportion event, and NASA or any other agency knew of it, would the public be told? Would it be hushed to reduce panic or advertised so we can get those last-minute chores done before vaporization? What's your take? I guess it depends on the event. So if the event is something astronomical, then you really wouldn't be able to hide it. Like if there was an asteroid that was inbound on Earth and NASA and various astronomers around the world had detected that this was the case, then we would all know about it. Because it's not like an asteroid is detected and then NASA confirms the death of all humanity, and then that's that. But what happens is an asteroid is detected, and there's a slight, tiny chance that it's going to have some kind of impact event with planet Earth decades down the road. Think about asteroid Apophis that we've all heard about, right? That it has a flyby, and then another flyby, and then maybe on the next flyby, there's a chance that it's going to hit the Earth. And now even that's been ruled out. And so what happens is astronomers are studying the sky, they're finding all these objects, and then they're detecting ones that are interesting, kind of potentially dangerous. And then they're doing many, many more observations, talking to each other, trying to do better observations to get to the point that they can rule it out as any kind of danger in the future. So I think that if you had something that was very science-based, I mean, look at, for example, a disaster that is ongoing and unfolding that is going to impact probably all of humanity. Think about something like global warming, that scientists have been deeply in the open. They've been attempting to convince people. People have been agreeing, not agreeing. Countries have been taking action. Countries have been delaying. That's what it will look like, no matter what kind of existential situation. I mean, global warming is potentially an existential situation for civilization and humanity. And they haven't been quiet about it. They've tried to get the word out. So I think you've seen plenty of examples. So no, I can't imagine any scenario where if anybody knew that the destruction of planet Earth was imminent, that they would attempt to keep it secret. They would attempt to share it with each other, try to sort out solutions, and try and figure this out right to the last minute. Frederick Fairvald. We now say that our solar system is atypical for a solar system because we keep finding systems not like our own. But how likely is it that this is just because of how we currently are able to find planets and the limitations that we face, and our system is actually the more common one? Before astronomers had found any other examples of exoplanets across the universe, the opinion was that the solar system was probably fairly normal because we have a bunch of examples of the same thing. We have the sun, and then we have 4 terrestrial planets, Mercury, Venus, Earth, Mars. We have 2 gas giants, Jupiter and Saturn. We have 2 ice giants, Neptune and Uranus. And so we have copies. And then each of the planets has moons. The biggest planets have the most moons. The smaller planets have less moons. And so it seemed like that was a very common thing that we'd find out there across the universe. Just examples of solar systems just in various different configurations. And then, of course, as you know, the first planets that were found, apart from planets found around a pulsar, were these hot Jupiters that were found around planets that they were, many times the mass of Jupiter, orbiting within, a few days to go around. It was like completely different than anything we had ever expected, but they were easy to find comparatively to the rest of the planets out there. And now, as astronomers are finding more and more planets, as their techniques are getting better, they're starting to find that our solar system isn't that weird. In fact, there was some interesting research that found that, they're now starting to detect gas giants out at the kinds of orbits that we have with Jupiter and even Saturn. And so they're finding them out there. And so I'll bet, like, when the full census is done, the solar system won't be super bizarre for a planetary system. You're going to find definitely the ones with weird configurations, hot Jupiters, no terrestrial worlds, no gas giants, etc. But you're probably going to find this combination of terrestrial worlds, gas giants, ice giants, and other interesting things. I mean, there are some classes that we don't even have, like super Earths, mini Neptunes. So there's definitely going to be some systems out there with classes of planets that we don't have. But I don't think we're going to end up feeling like we're that normal or that abnormal. Second, Dimmeryapan. Can we detect a breakthrough starshot coming from Alpha Centauri? I've been thinking a lot about it, and here's my take. Size is a big issue. I don't think that we have a telescope that can detect a single couple of meters big object. Maybe we can detect a swarm of them. So if there was some other civilization that had sent a breakthrough starshot at the solar system, so sort of think about this, right? That this other civilization fires up 1 million lasers, fires them simultaneously at these tiny little space probes, sends them on their way towards us. Now, we would not be able to detect the actual spacecraft. I mean, even if the spacecraft were well within the solar system, there was no way that we would be able to detect something that's a couple of meters across. Like when you think about, we can only detect asteroids a couple of meters across, just like within the orbit of the moon. So it's pretty hard to go much farther than that. There's no way. Maybe if there was a gigantic cloud of them, maybe we would be able to detect that, but even that would be outrageous. No, the way that we would detect them is we would detect the laser. So if they fired 1 million lasers all together with petawatts of energy directed towards the Earth, that would be a pretty significant thing that we would probably spot. In fact, for the longest time, people thought that fast radio bursts, which are fairly recent, they didn't know what they were. And sort of one crazy idea, it's possible Avi Loeb was one of the ones who calculated this, was that this was other civilizations firing out their giant spacecraft using lasers. And so the flash was the laser firing, and then it's red shifted by the distance to it into the radio spectrum. Now it looks like fast radio bursts. Many of them are coming from within the Milky Way, and they're probably just magnetars with reconnection events on their surfaces and not extragalactic civilizations sending breakthrough starshot spacecraft on interstellar journeys. So we would detect the laser. Now, if let's say the spacecraft didn't use the laser technique, what if they had giant fusion drives and they were coming towards us? Well, then we might be able to detect them, because you've got this giant spacecraft that's going at some significant portion, some fraction of the speed of light. It has to turn itself around, fire its fusion drive towards us. That's going to be very hot, putting out a lot of heat. It would be very bright in the infrared spectrum. And so if there was an alien invasion fleet on its way and they were on their deceleration burn with their fusion drives, it would be very clear to astronomers using infrared telescopes that something weird was on its way, especially as they got into the solar system itself. But they would probably be able to detect them for many light days away from the Earth. Jeff Sonderman. Hey Fraser, how much are we going to know about China's rover discoveries and observations on Mars? Do they disclose less or more slowly than NASA does? Yeah, China discloses very little about what they're doing on other worlds. Now, they've gotten better for the longest time, especially with their human spaceflight. You didn't see much just kind of propaganda from various state media when something had launched or something big had happened, but you didn't get all the details in the way that NASA does. Like NASA takes all of the pictures coming from the rovers, dumps them onto a drive that's available on the internet. And if you want, you can browse through the hundreds of thousands of pictures that are being taken by Curiosity and Cassini and so on. And China does not do that. But to their credit, they are getting better. With the Chang'e 4 mission, they had pretty good website. When as they took new pictures, they'd post the pictures onto the website. And in fact, I was able to find quite a lot of interesting news on their website that sort of hadn't made its way through regular media. So that was like the first place they did was they posted new pictures, posted a press release, posted even some journal articles onto their website. And so, we're expecting we're going to see the same thing. But even so, like with the Tianwen lander, we didn't really get a chance to see any pictures, anything that happened for a couple of days after the mission had been reported safely landing on Mars. And you just got to assume that's going to be the case. So they're sort of in a bit of a gray area on this one. It's not like it's a military thing. They are science missions. They are looking to share their information with the rest of the science community. But at the same time, it's got to run through the sensors. So I think you're going to find that it's not going to be as quick to send out information as we want. We're going to have to sort of dig for it, summarize it. We're going to have to pull it out of Chinese state media. There's a lot of interesting stuff on like Weibo and WeChat. A lot more information about what's happening in China than on Twitter and things like that, because it's sort of for a local audience. So no, we're not going to get as much information out of China as we get from NASA. I wish it was different. I wish they were better, but they're not. Dylan Troyer, how hard would it be to use space junk for in situ resource utilization, i.e. breaking down a spent second stage into feedstock for a 3D printer? Are there any legal rights or issues that would prevent that? I mean, I guess the question is like, how difficult would it be to take a fairly complicated piece of space hardware that's got lots of different materials, plastics, metals, electronics, and trying to dismantle it in a way that you can use it as a feedstock while you're in space? It would be pretty tricky. I don't think we are very good at being able to do that kind of thing. Like if you just dropped a computer down and fed it into the hopper of a 3D printer, like some dead old Apple II, could it turn that into feedstock for being able to do 3D printing? Like we're just not there yet. Now there are probably large chunks of, say, aluminum or steel that you could probably get your hands on. But again, it's sort of a fairly complicated operation. For now, we haven't really even mastered 3D printing in space using like the nicest, most pristine printed materials. Like you would send up buckets of broken up aluminum or buckets of broken up plastic that you could use as feedstock for your 3D printer. But I can imagine in the future, for sure, as we get much better at dismantling stuff, being able to feed them into our 3D printers, being able to use space junk for some new purpose. Now, the problem is that it's always going to be so expensive and complicated to chase down a piece of space junk. Now, it might be there's some big ones that are worth it, like giant second stage boosters where you can send a tiny CubeSat that will catch up with the booster, latch onto the side of it, and just start dismantling the booster bit by bit, turning them into feedstock for a 3D printer. But then you're still on that same orbit. If that's what you want to be on, then great. But chances are you have some different plan for your orbit. So I can't imagine, like, any plan to try and harvest space junk has to deal with just the terrible reality that all this junk is moving at just ludicrous speeds. And each one is on its own special trajectory. And so the only way to clean up space junk is to chase it down one piece at a time. And so you're having to accelerate your chase vehicle to the same speed as the space junk, which is going to cost you millions of dollars when it's cheaper to just launch something new from the Earth. So unfortunately, it's not about the junk, it's about the velocity for space junk. Julian Bastian, what are your tips to aspiring astrophysicists? All right, so keep in mind that I'm not an astrophysicist. I'm a space science journalist. And so I could give you plenty of tips about being a space science journalist, but less about being an astrophysicist. Now, I am good friends with many of them, and so I've watched them from afar. And I think my tip is that it's hard and that it's very difficult to actually get a job in this field, that you have to go to school for your bachelor's degree, for your master's degree, and then you have to get your PhD to be recognized as a researching astrophysicist. So right there, you've got 4 plus 2 plus 3 years plus some postdoc. You're looking at 10 years of schoolwork, which is going to be incredibly expensive. You start to get paid by the end of it, but still very expensive. And then you're looking at sometimes 100 to 200 people attempting to get the same position. And so you have to sort of make a lot of compromise. You have to kind of go where the work is. So it's fiercely competitive, not well paid, a lot of school, very expensive to get that job as an astrophysicist. And you could tweak things slightly and take computer programming instead, and you could walk away almost 100% chance of getting a job at a fairly good firm and making 100,000+ a year, and it's super easy, and you can live kind of where you want. You can work from home. So if you want to be an astrophysicist, you have to be really serious about it. And you have to accept the fact that it's almost certain that you're going to have to accept some other job in some other field that isn't being a professor or researching astrophysicist. It's just really tough. And I think, as much as I'm a fan of space and astronomy and all of the people who are doing this work, I think we need more funding so that more people can have jobs in this field than all the people who are going to school and hoping that they're going to be able to turn this into a career. So I think that's it, is like, be really, really sure and have a backup plan. That, computers are the one that I always recommend. So go into university, definitely study astrophysics if you want, if that's what you like, but also consider engineering, mathematics, computer science as your fallback. Take them both at the same time. And then you can come out the other side and go, you know what? I'm just going to go and work for Google because I haven't been able to find a job in astrophysics. So that's my recommendation, which I know isn't sort of the one you want to hear. More questions in a second, but first I'd like to thank our patrons: Bob Harkins, Brian Shoemaker, Choo Choo, Terrence Branscombe, Randy Brace, and the rest of our 831 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Horizon Brave. Do you think they'll ever do another Grand Tour mission? Maybe not even for our local system, but in the future, some great alignment for a long-distance tour of multiple stars? Well, that's like two different questions. So the Grand Tour was this incredible opportunity that NASA realized during the 1970s when they were planning out the Voyager missions. They realized that, they could get these gravitational slingshots from Jupiter, Saturn, but also, if they time things right, they could also visit Uranus and Neptune at the same time. And so when they sent the Voyagers, one Voyager just did Jupiter and Saturn, and the other Voyager was able to do a flyby and go all the way out to Uranus and Neptune. So Voyager 1 just did the 2 planets, Voyager 2 did all 4. And that was incredible. And when you think about how long it takes for the planets to go around the sun, Uranus takes 84 years, Neptune is like 160 something years. So the chances that they were lined up perfectly for this doesn't happen once every few hundred years. It'll happen again in the future, but not within our lifetimes. So this was an incredible opportunity to do it, and they had to. Will it happen again in the solar system? Like I said, wait a few hundred years, it'll happen again. Now you can get like a Saturn, Jupiter one, but to get all 4, it's crazy. Would we do it for star systems? Now, the idea of a gravitational slingshot will still work from multiple stars. So you could definitely do a gravitational slingshot going to a nearby star system and then another nearby star system and speed up each time. And when you think about the number of stars out there, there's going to be all kinds of alignments that you could use to tweak yourself to go from one to the next and just go faster and faster and faster. I'm sure at some point someone's going to work out some kind of complicated computer algorithm that will constantly be watching all the stars and plotting out perfect trajectories. But no matter what, it's still going to take thousands of years at our current technology to be able to send a spacecraft, even to Alpha Centauri. I'm like, I know, Breakthrough Starshot, sure, maybe, but still, you're looking at hundreds of years to get to the first star system, and then maybe you crank around to a gravitational slingshot and go to your next one, and then you got hundreds of years to get to the next one. and so on and so forth. So maybe, I mean, who knows? The other option is to just wait for the stars to get close to us and then leapfrog from star to star. And I wonder which will be the faster approach. I don't know. Time of dying 00. What determines how far away a planet's orbit is from its star? I imagine this happens as its orbit normalizes itself. All right, so let's talk about the solar system as a way to sort of think about this idea. So 4.5 billion years ago, you've got the solar nebula. And inside the solar nebula, you've got hydrogen, helium, heavier elements, and some event collapses it down, like a supernova comes by or two gas clouds crash into each other, and it starts to collapse this cloud of gas and dust. And as it collapses, it starts to spin up because each individual particle inside the cloud, it's got its own velocity. And so it all starts to sort of pull together. It starts to spin up and average out the momentum, the velocity of all of these particles. And eventually the thing spins up so fast that it flattens out into this disk. And at the center, you've got the star, and then you've got the accretion disk around it, the planetary disk that's forming around it. And then inside that planetary disk, you've got little pieces of dust and dirt that glom together with maybe electrostatic forces, turn to larger and larger objects. And as they become more dominant, they start to siphon away material like the lines in a record, although you probably don't even know what a record is. Anyway, you've got these grooves that are forming inside the protoplanetary disk where you've got these newly forming planets forming. And they will feed off of the region around them, and you're going to have, like, wherever one of these objects is able to feed inside this planetary disk, you're going to get a planet. Now, things are made a little more complicated because as the planets get more massive, they start to pull themselves like they're pulling on a rope. They're able to move and drift and shift within this accretion disk. And so we know that in the solar system, billions of years ago, that Jupiter, Saturn, Uranus, Neptune moved, they shifted themselves out quite a bit in the solar system, possibly very quickly. And in fact, it looks like Uranus and Neptune actually switched places during this process. So back to your original question, what determines how far away the planet's orbit is from the star? It's like where it formed in the accretion disk and then where it migrated to after all of the planets had formed and sort of figured each other out and balanced themselves across the star system. Arjun, does Jeff Bezos and his brother going to space mean we're going to get more development from Blue Origin? Do you think they will match SpaceX's pace soon? So in case you haven't heard, Amazon.com's Jeff Bezos and his brother are going to be flying on a Blue Origin New Shepard mid-July. And they just recently auctioned off the ticket to go with them for like $28 million or something. So that's an expensive trip, but I guess you get to sit beside Jeff Bezos and go on that flight. Will that increase the speed of Blue Origin? I don't know. At this point, Blue Origin is clearly losing ground to SpaceX. I mean, they have been working slowly but surely, but more on the slowly side. And now they've lost a big contract with NASA, potentially, unless they're able to convince NASA to take them back. So they've lost a contract to provide a landing system. We're now thinking that the New Glenn won't be launched until 2023. I mean, we should be seeing starships fly. You could take New Glenns, put them inside starships and fly them to space. Well, not exactly, obviously. So anyone who wants to compete now, if Starship works, is going to have to come up with their own version of the fully reusable rocket. And I think there's only Vector Space, Reaction Space was the only one who's come up with a plan for their own fully reusable rocket. Like no one else is announcing these things. So will Blue Origin move faster? Bezos has said that he is stepping down from Amazon, and you would assume that one of these reasons is because he wants to spend more of his time on Blue Origin and maybe the Washington Post or something like that. You hope that this would mean that he would be able to accelerate the development, but it could just be that's the corporate culture that's been baked in, and it would be a really hard time for them to be able to accelerate things, to catch up and leapfrog what SpaceX is doing. And that's really sad because we need a competitor. We need someone who is keeping SpaceX honest, being able to, maintain their competitiveness. And it really looks like SpaceX at this point is just running away with the whole show, which is bad. Like a lack of competition always ends up bad. You want there to be competitors going back and forth. So will it speed up? Maybe. But I suspect it's going to be too hard for them to really catch up to what SpaceX is doing in the near term without some dramatic shift in the way the company's done. Like if Bezos announces that he's firing everybody and going back to, he's starting to build towers of stainless steel, then maybe, just outside Seattle, maybe. But if we don't see something dramatically different coming out of Blue Origin, they're just chasing yesterday's technology at this point. Miguel Angel Romero. I heard your interview with Michio Kaku, and I keep thinking about his idea of a civilization that could explore the universe transformed into a beam of light. Could you explain it again? Yeah, it was funny. Like, I think, Michio Kaku had a lot of canned responses during our interview, and it was sort of a challenge for me as an interviewer to get him out of his comfort zone and talk about some stuff that maybe he hadn't spent a lot of time already thinking about. And this was sort of one of the directions that we went to. And honestly, he gave one of the best explanations or answers to the Fermi paradox that I had heard. And I was quite impressed. And what he was saying is that a future technological civilization like us, like in the future, we will eventually digitize ourselves. We will merge with our computers and turn into some kind of robotic, computer-based civilization. And that doesn't seem that impossible. As we get Neuralink and other things, I can imagine us merging with our computers in the future. And then he said, well, so then once you are a digital civilization, then you could set up some kind of receiver on some planetary system, and then you would transmit yourself from one star to another star through this network. You would essentially turn yourself into computer code. You would beam that computer code at some other world, and then you would be rendered out in some other way on that other planet, and then you would have essentially traveled at the speed of light. But because you're traveling at the speed of light, you don't experience any time. And so you would just hop into the teleportation machine. You would arrive at your destination instantaneously. And he said, well, so maybe the reason we don't see any aliens is because they have all ascended to become a computer civilization. They are beaming themselves from world to world. And we just don't see this because it's really hard to detect a beam of light that is moving out there in the universe. And I thought it was a great idea. I liked it. So there you go. That's the future. And it doesn't seem like an impossible future, is that we will transcend our meat bodies, turn ourselves into digital. We will transmit ourselves via some kind of encoded beam of energy. The trick is, and this is what I brought up with him, was that we would need some kind of receiver that would be able to receive the data stream, because you can't just, if you digitize yourself, turn yourself into a laser beam and fire yourself off at another star system, you're just going to warm up one of the planets a little bit. You're not actually going to be able to be downloaded and decoded and turned back into some sort of physical being without the receiver. And so where are the receivers? So, but still, I love the idea. And although it sort of came across as a fairly mystical sounding concept, it actually feels like a very likely future, that it feels kind of inevitable that we will eventually merge with our computers, and that's how we'll explore the universe. Estevan Kendall. If dark matter is everywhere and it only interacts gravitationally, should we expect the center of massive objects such as planets and stars to have a higher concentration of it? Can we measure it? So I actually did an interview here on this channel with a researcher a few months back about this idea of being able to detect dark matter because it could end up inside the gravitational well of stars and planets and even the regions around black holes. And so astronomers have detected an excess amount of radiation coming from the center of the Milky Way, from the supermassive black hole at the heart of the Milky Way. And one of the ideas is because dark matter is annihilating essentially dark matter has fallen down into the region around the black hole, is crashing into each other in this sort of more dense region of dark matter, and we're detecting the gamma radiation that's coming from it. So yeah, in theory, dark matter should be ending up at the bottom of various gravity wells and having some kind of impact on the region around it. Around a black hole, maybe it's causing more gamma radiation because it's annihilating itself. Inside a star or planet, it could theoretically even be heating up the planet or star in a way that's detectable, that there is actually dark matter in it. So this is a pretty intriguing idea as a way to find dark matter out there in the universe. Joshua Bingham: if extraterrestrial life were to exist, would it have to be multicellular? No. In fact, most astrobiologists believe that the vast amount of life that's going to be out there is going to be single cellular. It seems like a much simpler evolution to have single cellular life than whatever incredible event happened here on Earth that created multicellular life. I mean, all of the animals, plants, those were all some incredible moment where two cells somehow merged into each other, and you get the mitochondria and the rest of the cell, and it doesn't seem that it's ever happened again on planet Earth. And so whatever event caused it, it seems to be very rare. And so the expectation is that across the universe, we should find plenty of single cell life, but might be that event going to multicellular life was very rare. It's this idea, it's called the rare earth hypothesis, and there's a whole book about it and lots of other documents out there that you can read. Now, that said, I don't find that like a really compelling reason why we don't seem to see any evidence of aliens out there. It feels to me like even single cell organisms should somehow in large groups be able to mimic some kind of more complicated behavior. I mean, we see some of that here on Earth, but you can imagine a huge colony of single-celled organisms somehow becoming more intelligent, an emergent property of enough of them gathered up together. But still, it seems pretty reasonable that even if we find life on Mars, it'll be single-cellular. Even if we find it in the oceans of Europa, it'll be single-celled. And if we do eventually make our way out to another planetary system, it might very well be that it's single-celled. And we might go a long time before we find anything that's as complicated as the kinds of life forms that we have here on Earth. Thanks, everyone, for watching this week's QA. Again, I do these live every Monday at 5 p.m. Pacific time. So if you want to join, watch live, come onto my YouTube channel. There's events for all the future shows, and you can pick the one and join live and ask your questions and do follow-ups and so on. I hope to see you here. All right, thanks. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links you can find out more. And I write every single word. Go to universetoday.com/newsletter to sign up, and it's totally free. Did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.